Today what we're going to do, we're going to study hyperbolas. Here's the lesson plan, and more importantly, the homework. So let's see why. Why study hyperbolas? Well, there are certain comets whose paths are actually hyperbolas. So there are celestial bodies whose paths are hyperbolas, but they also have another use. They can be used to track ships or airplanes. You can read more in the book about how they can, how hyperbolas are used for tracking ships and airplanes. What is a hyperbola? Well, this is what the graph of hyperbola looks like. Just like an ellipse, a hyperbola is a set of points. Unlike an ellipse, for an ellipse, we remember the sum of the focal radii was a constant. For hyperbola, the difference of the focal radii is a constant. So anyways, let's read the definition. A hyperbola is the set of all points in the plane such that the difference between the distances from P to two fixed points is a given constant. Those are the two fixed points. They are known as the foci. So let's write things down. F sub 1, F sub 2 are called foci. Same name as for ellipses. P F sub 1 and P F sub 2 are called focal radii. And then this time the difference, we can clearly see that P is closer to F sub 2. So there are two things that we can do right now. One, think of P as an arbitrary point where we don't see it, and you could just say the absolute value of P F sub 1 minus P F sub 2 is equal to a constant. We call that constant 2a. Or if we don't want to use absolute value bars, well, that would be kind of hard because we just chose a random point. Point P doesn't have to be there, it can be anywhere at all. So let's choose another point, let's call it P sub 1. And this time, P sub 1 is closer to F sub 1 than it is to F sub 2. So this time, we couldn't just write P sub 1, F sub 1 minus P sub 2, F sub 2 is equal to 2a, because this would be false. So that's why we need the absolute value bars. P being an arbitrary point, we don't know whether it's closer to the focus on the left or the one on the right. Okay, let's actually do an example. For our example, we have find the equation of the hyperbola having foci -5, 0, and 5, 0, and difference of focal radii equal to 6. So I'm going to go back to our example, and I will erase P sub 1, we don't need it. I'm going to write down some of the information that we have, like the coordinate of the second focus is 5, 0. The coordinates of the first one is -5, 0. And the coordinates of P, since this is an arbitrary point, is x, y. Now, I chose this point to be closer to the second focus, and so I'm not going to use absolute value bars this time. From our illustration, from our graph, from our diagram, you can see that Pf sub 1, the distance from P to the first focus, is greater than the distance from P to the second focus, and this is equal to 6. So the difference of the focal radii is equal to 6. So we're going to set it equal to 6. We're going to now use the distance formula, just like we did for ellipses. We're going square root of x plus 5, quantity squared, plus y minus 0, quantity squared, minus square root of x minus 5, quantity squared, plus y minus 0, quantity squared, is equal to 6. We don't like having square roots on the same side, so what is my goal? My goal is to take this equation, which involves two square roots, and transform it into one that looks like x squared over a squared minus y squared over b squared is equal to 1. So I'm going to separate the square roots. We have square root of x squared plus 10x plus 25 plus y squared, and to get this square root, to get rid of the square root on the left side, I'm going to add it to both sides. Yeah. Plus square root of x minus 5, quantity squared, plus y squared. We add it to both sides. So we have on the right side 6 plus the square root of x minus 5, quantity squared, plus y squared. Let me erase a little bit because we're getting too crowded, and everything is crowded. When everything is crowded, it's harder to understand. So on the left side we have the square root of x squared plus 10x plus 25 plus y squared. On the right side we have 6 plus the square root of x squared minus 10x plus 25 plus y squared. We're now going to square both sides. Our goal is to get rid of the square roots. So let's square them. Left side is easy. We just get x squared plus 10x plus 25 plus y squared. For the right side, we're going to do a little bit of scratch work. We're going to write the quantity that we see here twice. So we're going to have 6 plus the square root of x squared minus 10x plus 25 times 6 plus the square root of x squared plus 10x, not plus, but minus 10x plus 25. Let's multiply. 6 times 6, 36. 6 times the square root is 6 square root of x squared minus 10x plus 25. The square root times 6, that is another 6 square root of x squared minus 10x plus 25. And then the square root times itself is just going to be plus the square root of x squared minus 10x plus 25 plus y squared. Look at that, I forgot to write the y squared for both of them. So plus 25 plus y squared. All squared. So what is this? This is our right side. The right side is 36 plus 12 square root of x squared minus 10x plus 25 plus y squared. I'm going to have to erase all my work. Plus x squared minus 10x plus 25 plus y squared. Look very carefully at both the right side and the left side. What do we see? An x squared on both sides. Let's subtract x squared from both sides so we don't have to deal with it anymore. What else do we see? a y squared on both sides. The y squared is also gone. And there's a 25 on both sides. So now on the left side, all I have is a 10x. So we're going to now isolate the square root from everything else once more. So we're going to add 10x to both sides. And we're going to add 36 to both sides. The left side becomes 20x plus 36. The right side becomes 12. I said I'm going to add 36. I'm not. I'm going to actually subtract 36 from both sides. 36 plus 36 would be 72. We actually want to get 0. So yeah, 20x minus 36 is equal to 12 square root of x squared minus 10x plus 25 plus y squared. Look very carefully. 20 is divisible by 4, 36 is divisible by 4, 12 is divisible by 4. Clearly, I'm hinting that we're going to divide everything by 4. So we have 5x minus 9 is equal to 3 times the quantity x squared minus 10x plus 25 plus y squared. Okay. Again, I want to get rid of the square root. So one more time, we're going to square on both sides. I'm going to need space. So I'm doing fine. Just move the problem here. 5x minus 9 quantity squared. That is 25x squared minus 90x plus 81 is equal to 9 times x squared minus 10x plus 25 plus y squared. We're almost done. And I have good news. You don't have to use this method. What you are doing, the homework, this is just to see the main characteristics of a hyperbola. And so we're only using the definition once, this one time. Let's distribute the 9 on the right side. So we have 25x squared minus 90x plus 81 is equal to 9x squared minus 90x plus 25, not plus 25, plus 225 plus 9y squared. Notice that we have a negative 90x on both sides. So, add 90x to both sides, subtract 81 from both sides, subtract 9x squared from both sides, and subtract 9y squared from both sides. And we're almost there. Let's see what I've got. No more 9x squared. No more 90x. So on the right side, we have 144. On the left side, we have 16x squared minus 9y squared. The journey is almost ended. Why are we coming all the way over here? Because I want you to see what form we want our equation to take. So let's write this one more time. 16x squared minus 9y squared is equal to 144. So to get a 1 on the right side, we divide everything by 144. And we are done. The ordeal is over. We survived it. We're ready to look at some characteristics of our hyperbola. Okay, I'm going to repeat this one more time. This is not how you will do the problems on the homework. We will provide you with formulas so that you cut this time in half. And that's it for this example.